Hello, can you hear me?
Yep.
Exactly.
Thank you. Thank you very much. I am going to start projecting my screen and we should start discussing our agenda. We'll be there just a minute. I am making sure that we are recording and I think we are. Okay, let's check. Yes, we are recording. So I just want you to know that we are recording and we were discussing the last time. I'm not sure if you have had a chance to review, but we were using Ansible and we were able to accomplish installation of, if I remember right, the exercise we did was installation of Docker using Ansible. I think that's what you remember, right? Is that what you remember? I think that's my memory. So let me get to that exercise again and we'll expand the concept first. I'll explain the concept that I want to bring up for you and then we'll do that next set of exercises. So the thing that I want to highlight first of all is this idea that we have been able to use a product called Ansible. And using that, we were able to convert a bunch of machines out there in a variety of clouds. You know, depending on what machines we get, whichever cloud we use, we are able to convert them as a place to run Docker, a place to run Docker containers. That's what we have been able to accomplish in the previous exercise, which I think I ran right here in a repository that I gave you in Slack chat. So you should have a link there. And that will contain the collection of folders and Ansible package, basically, the Ansible folder of, there is no name that like kitchen in here for Ansible. So there is no such name here, but I just call it a folder for Ansible. And in that folder, what we have is this location, which allows us to create a machine, converted into a machine, a place to run Docker containers using this role that we were able to get from the Galaxy. If you remember, Galaxy is a place to grab roles, ready-made roles that we can use with Ansible. And we were able to go to the Galaxy and grab one of the roles that I like for use with this idea. And we were able to accomplish that idea in a variety of clouds. Now, having done this part, the next thing to explore and further expand and our understanding on how do we actually put these containers to large scale use. When we are putting machines, these, let's call it M0, M1, M2, like that, any number of machines we have in any number of clouds, each one of them is capable of running, say, for example, Docker containers. So that's the setup that we now have. But then we are still tasked with the responsibility of managing these machines. And that is something that I want to abstract out further. What I really want to accomplish is a situation where I'm abstracting the machine infrastructure and I'm just dealing with only the containers, only containers. That's what I really want to deal with. So that I can then move these containers around. What I really want to accomplish is something like this. Imagine this picture that you have seen before. And we have these machines and more machines like that. And we were able to convert these machines in a place where we can then run containers. And not just one, but many containers. Each of these machines can run any number of containers, as you saw. And these C's are representing containers running in those two machines, this one and that one. And what I want to be able to actually do is get a point where I'm not even bothered or interested in dealing with these machines as such, but all I want to do is, put them in a place somewhere in mental abstraction. So they will exist, but I will not think about them too much. What I really want to do and think about is my application. What I really want to worry about is these users. So these people will connect and they want to interface with my application. And that is what I really worry about and make sure that these people are happy. And for that application to run, I want to provide containers. And so I would like to deal with these containers as a whole, and not deal directly with machines and patching and upgrades and maintenance and all that. So that's the situation. That's the scenario that I want to enable. I want to abstract away these machines and deal directly with containers. That's the kind of setup that you see today in most modern clouds. They are providing these kind of setups in a variety of implementations. I'll give you some names, and then we'll do one of our implementations ourselves. So here is the news from 2 days ago about Azure ACS. What do they call it? Let's go search. So there is this news about Azure yesterday, 2 days ago. No, 2018. I'm trying to find out that news. ACS on campus. No. Let's go to Azure website. They will probably have it there. Azure.com or Windows Azure, whatever that name of the website is. But here we should be able to find a product. And again, it's very hard to find things on Microsoft for some reason. So products, and I get lost. Containers, container service. And here is somewhere, there is this public preview. I think that's the news. So here is the news. No, it's not the news. So bottom line is there is this thing, a similar thing from another company, Amazon. They have a thing called Fargate. And this Fargate is somewhat easy to run, easy to search. And let's look at the top level news about what that Fargate is doing for us. What we are doing is running containers without managing infrastructure. So we are not dealing with machines. We're basically dealing directly with containers. That's the kind of scenario that people are evolving towards. Amazon's example of Fargate is one such implementation. Microsoft has also come out with a similar implementation, and Google already has it. Google calls it the Kubernetes implementation. So in which, if you go to the cloud.console.cloud.google.com, they already give you a implementation called Kubernetes, which is one of their products, and they have it available for quite some time. It's called the Kubernetes engine. Now that GKE is what they call it, is available where you deal with directly with the containers, and you don't have to worry about underlying machines because Google will manage it for you. You don't have to worry about these things, worry about the machines themselves. So that's where the part I want to strike off and just deal directly with containers. So there are a variety of these solutions coming out. Some name product from Azure Cloud, which I don't know what exact name is. From Amazon Web Services, the name is Fargate. And these are the two products that we see recently coming out from these two companies. On orchestration side, we have an open source product called Kubernetes already available from Google. These guys are also creating the same product set that matches Google Kubernetes engine. Amazon calls it Azure Amazon calls it Elastic Kubernetes Service. That's the name. And Azure calls it Azure Kubernetes Service. Maybe they call it Azure Kubernetes Service. I don't know what acronym they use, but they are basically these. And there are more such products to orchestrate containers. So one of them is Docker-based, a Docker company-based. The Docker company has produced a product called Docker Swarm. And this is the exercise that I will be doing today. It is built into Docker component product itself. So when you install Docker, it gives you Swarm capabilities already. And we have to invoke them. Now, these capabilities of Kubernetes and Swarm essentially are a method in which what we do is we are dealing with, let's say, for example, a situation where we have just began with some raw infrastructure. Yes, we are dealing with machines right now. So here is a machine, here is another one, and here is another one. So 3 machines, let's take for example. And we are beginning with the simplest example to construct what is called a collection, or you can call it a cluster, or you can call it a bunch, just basically a bunch of these things called machines. And that's what these things essentially are. They're put together, machines put together. They call it a cluster, a bunch, a collection. You can name it whatever you like. But bottom line, some of these machines will operate like managers, and the others will operate like workers. And you need to have these worker machines very powerful, because that's what really dictates how much horsepower can you provide to your applications, because these worker machines are actually doing the work. These manager machines are basically supervising the workers. They're supervising. So in effect, you can have a situation where you have managers M0, M1, M2, M3, like that, any number of them, as long as it is an odd number. Typically, people have like one manager or three managers or five managers. That's the kind of situation you will mostly see in enterprise deployments, 5 managers. And then to have a bunch of workers controlled by these managers, you can have any number of workers like that. And it doesn't need to be odd or even, it doesn't matter. It can be any number from, say, 1 to infinity. So any number of workers that you may have, you can construct a cluster or a bunch or a collection of machines like that, and then have them interoperate among themselves and deal about disaster, about a machine disappearing. Like, for example, say for this machine goes away, and then the other 2 managers will take care of it, and they will elect somebody who's going to handle the actual action of managing these workers. And they will be able to decide and appropriately take corrective action about decision making as to what work goes to which worker machine and like that. And that's the kind of situation that you will see when machine goes down. You want to bring that back up and put that back in action. And that situation is where you will see odd number of managers taking care of a cluster, for a given example. Similarly,
So what has to be odd numbers of the managers?
So the managers need to be odd numbers for purpose of electing a leader. What happens is if you have 2 managers or even number of managers, then this election will fail. If 2 people say yes and 2 people say no, then you don't know who is right. So you need to make a decision as to who is it's like an election, right? You have to have an odd number so that you can actually find a 3-to-1 relationship, or no, not 3-to-1. So if you have, say, 3 people, three machines here, so 2 will say yes and 1 guy will say no, then you have a decision already there. This is the decision, right? If 2 people say no, 1 people say yes, then you have a decision. This is the decision. That's how you can decide, and having an odd number will help you make that decision. When something goes wrong, when data gets corrupted, the odd number of managers will be able to help you make that decision, which is the right action to take in case of something going wrong. That's the reason why we typically keep managers in odd numbers. Now, does that answer your question?
Yes.
Oh, good.
Thank you.
Okay. So in workers, you can have any number. So that's the kind of operating principle or underlying concept that I want you to think about. So these machines will be able to manage themselves, and we will be able to use them from a container usage perspective. So now, to enable this kind of a scenario, we need to have a simple setup to understand what constitutes a cluster. So let's say you have, very simple example, 1 manager and 2 workers. Like that. And so in order for this 3 new brand new machines, for them to come up and become a cluster, you need to do certain things so that they will cooperate and act like one large pool of resource. And the simplest way to think about these things is to have this machine generate some kind of a secret. Secret. And then, you should get that secret out. So get it out. And then use that secret and give it to these guys and this guy. And say, you use that secret and join this master or the manager. Join. And when you have the secret with you, and use that secret information to join and tell manager you want to become a member of the party, member of the team, member of the cluster. Then once you are joining like that and you know that there is a secret that the manager generated and you're using that secret to join, then it will be a complete handshake. And then you have a cluster of 3 machines, for example. And then these machines will be able to identify, operate, and understand each other, and share load and things of that nature. You will see that in action as I go and describe and do it. But bottom line, this idea is the underlying concept in any cluster, generally speaking. Whether it is Kubernetes or Docker Swarm, all of these guys typically do the same thing. Same thing in Kubernetes. You have master or manager generate a secret, and this secret is passed on to any number of workers, and then they will join the master. And then they will all become one big family of cluster of machines. That's the kind of setup. Now, in order to do this, we will see a piece of Ansible code that will make this thing happen. And what we will actually do in an exercise is that we will take machines, rather, I should say, these 3 machines, and then convert them into a swarm, into a Docker swarm. And that is an exercise that I want to do live with you. And that is already written down in a repository. Now, where is that repository? That's what I want to grab. So I'm going to find it and then give it to you. I ran that exercise. It is here. No. That one. That's the exercise. So prepare swarm using Ansible, and let's see git remote. And the git remote is origin. And the link is right there. So I'll go to that link in GitHub and see what comes up. That's the link. That means this is the exercise. It's a public repository. And I'm going to give you that link so you can read it and do it. So here it is. That's the link. Up to the exercise. So we should sync, already up to date. So that's good. And I will open this up in Atom Editor. So I am in synchronization with what you see here on the website in GitHub. That means my folder matches this thing. And I have added some examples for us to play with. So there is a swarm set of examples and all that. But let's go, first of all, understand what this exercise will do for us. So since this exercise is kind of cryptic, you don't know what to do with it once you have the repository. You don't know what to do with it. So I will help you understand this and then run it. We'll run it inside our workstation. This VirtualBox workstation, which is starting up. And in here, we have a bunch of requirements. Like we need to have our Ansible deployed, Ansible set up already. Ansible is already set up in the Cloud Genius workstation. So in that workstation, you will find that we have Ansible already. We'll just go and check. So we should have that already, by the way. I think we already ran an exercise on Ansible, so it's there. Next, we need a library called JQ. This JQ library is a dependency for execution that I want to run. And what this JQ is actually used for is to collect the secret from here and then pass it on to these guys. And then they will be able to use it to join the cluster. And that's where this action of collection of secret and handing off to another machine is done by the JQ library. That thing is called JQ. I think it's already not installed, so we'll install it. So if it is not installed, we'll install it like that. We'll copy the thing and say copy and paste and run it. And it will install JQ. So it should be fairly quick. Next one we need is this Ansible check. We want to check for Ansible. Do we have Ansible there? I think we do, but I'll check. So that will allow us to actually execute these actions inside. So let's go check whether we have Ansible there. And I think we do. And yes, we have it. So that's Ansible taken care of, JQ taken care of. Now what we want to do is the next action is to make sure our public key is given to the cloud provider. So this is, in this example, I'm using some cloud called Vultr. It really doesn't matter which cloud you use. All you really getting is Debian machines. So we're going to get 3 Debian boxes there with private key networking enabled. So I will do exactly that. I'll go to this Vultr Cloud, and in there, I will log in. And this exercise, I think, is written in a fashion to make sure that we are working with the Vultr Cloud. I think this exercise requires, you can modify the exercise, but I think the way it is written is that it's supposed to work in this cloud. That's how I think I was playing with it, so I ran it to make it work with this cloud. We can modify it to other clouds, but there are certain subtleties that are necessary for us to make use of a networking capability. What I'm going to talk to you about is these connections, like, these connections that need to happen. This machine needs to talk to that machine, and that connection needs to happen like this and like that. And what I want to make sure that we do is that any machine that we have typically a Ethernet port facing the world outside, public internet, and then there is internal connection. And so what I want to do is that these machines that we get have a public facing connector and an internal connector, some kind of an Ethernet 0, ETH 0, which is public facing outside, and an internal one, ETH 1, like that. And this will be our internal network. And we would like any communication that happens between these machines and the manager machines on the internal network and not here. I don't want people to be communicating on the public network. I would rather have that discussion among, hey, can I give you my secret and join your cluster? That the discussion needs to happen in a private network. And that is one of the things that I think is necessary, that I have made some commits in this code that requires us some, I think this private IP, this YAML file, specifically number 2 YAML file inside the playbooks. There are a bunch of YAMLs here. One of the YAMLs is the one that is very specific to Vultr. And I think I mentioned it here somewhere that it is about the Vultr cloud. If you want to use another cloud, you have to make these changes to this in this particular playbook will not work. For this playbook is designed to work exclusively with that Vultr cloud. Just want you to know that. And that is what this private IP part is specifically written to handle Vultr cloud, not other clouds. We have to modify it. It'll work with other clouds also. So that's the reason why we are using this cloud, because I chose it to write it that way. We can modify it, and if you need, we can modify it to other clouds, and we'll make that work also. Not a big deal. But for now, let us get to the concept. The concept is we want to get 3 machines here in this cloud. So we will say, give me, please, in Seattle. And currently the location is sold out. Okay. It looks like it's a very popular cloud, or maybe it's a very small cloud, one of those things. So we'll go to some other location. For example, where do we go? San Francisco, are you there? Yeah, Silicon Valley. We'll go here, Silicon Valley. And we say, I want to give Debian 9 and give me the cheap machines. $5 are good. And then what I want to do is enable private networking. That's the key thing I'm talking about. That is, you need to have that capability in any cloud will give you. But this is the easiest one I was dealing with at the time I was writing the exercise, so I chose that. And I will enable private networking here, and then I will provide my public key. So here I have to give my IDRSA public key. And so I will grab that from my command line and say cat.ssh and provide the public key right here to me. and I'll grab it from here like that and give it to my vulture cloud like this and say add the key. So now they have my public key. Okay. And now what I want to do is get me machines. For example, get me a manager machine. And I need two more. So I would like to get a worker machine and a worker one machine. So I'm getting basically these three machines. And I'll deploy them. So let's go quickly summarize. What are we doing? We are getting a machine in some random location, Silicon Valley, Debian. We are getting the cheapest possible available machine, which is $5. We are enabling private networking, and we are selecting our key pair. Then we giving some random names. So they're not really random. They have some sense to it. So manager, worker 0, worker 1. So three machines deploy now. So three machines are getting ready now. And I will get these three IP addresses from these guys, and I will use them in our exercise here. What I want to do is I gave the public key to them, then get three Debian boxes, the three private networking enabled manager 0, worker 1. I think I chose the manager, not manager 0, but it's immaterial. Now, once I have that, I will get IP addresses from these three boxes and then provide it to my inventory, right? My inventory file is supposed to be written in the Ansible configuration, if you recall. Let's go back to our notepad, and you will see that there is this thing called Ansible configuration, which defines where is the file that contains the list of all my machines. It is that file called inventory, and that file is also known as inventory. The inventory will be stored in a file called inventory. Sorry, that inventory will be stored in a file called inventory, and that file is right here, inventory. And here I'm defining manager and then worker, and there is one manager here and there are two workers here. I need to know the IP addresses so I can replace these numbers like that and replace these numbers also like that. But remember, we need to do this exercise inside the VM so that you can also actually do the same way like I'm doing. So I'm not going to do it in the Mac, although it will work. I would rather give you an experience that you can reproduce and replicate exactly what I'm doing so that you will get the point across. So what I'm going to do is clone that repository from here, this location, clone, and use HTTPS to copy that link there and then bring it to here. Here and say git clone cloud, this cloud in here, these three IP addresses, I will label them correctly. I'm getting a notice that my internet connection is unstable, which is kind of strange. But if that is the case, please let me know if you're not able to hear me properly or not able to understand or see my screen properly. Please let me know. I just saw a notification saying my internet is flaky. Doesn't look like it, but whatever.
Yeah, Nilesh, I've had a blip or two, but they've been brief, so it hasn't been a big deal.
Okay, good to know. The internet seems to be okay, reasonable. So I'm not worried about it too much unless you tell me that there is a reason to worry. So, okay, fine. Moving on. So I'm grabbing these IP addresses. So let's begin with manager. Grab that, put that here in the VM. And in that VM, we have to go to that folder that we have cloned locally. And so we'll go to that folder. We'll go to prep and then open up Atom there and then fill it up. Fill up with the IP addresses that we just grabbed. So what I'm going to do is look at the inventory file and fill it up with the IP address of the manager like that. And then the next one, that there are two more. So there is worker 0 here, and that's worker 0. No, worker 0, please, nice. And then worker 1. And like that, now I have my keys in place. You will notice that I have some other variables here, like private key references, which is what I'm going to use. And that is the key inside my virtual machine, which is, you already know. And I'm using Python interpreter version 3 for Python 3, which is not necessary because we are using Debian, which already has Python 2 also, but whatever, not changing, keeping it like that. So inventory file knows where the machines are. So there is a manager machine and there are 2 workers. I'm going to save this file and close. I'll go back my Ansible configuration and check my configuration. It says inventory is to be stored in the file called inventory. I did that. Next, host key checking false and roles path. My roles are stored in a location called roles. My remote username is root. And there are certain other parameters like retry files enabled, no, and deprecation warnings are true, and force color is true. So these are cosmetic changes. We don't need to worry about them too much. You can read them about in the Ansible documentation as to what these things mean. But they're mostly cosmetic, not critical. Next, what I want to do is read. And so we have these 3 machines ready. Now we populate the inventory with the IP address of the boxes, which we did. And now I would like to run the play. The play actually runs in several parts, 0, 1, 2, 3, several parts, part by part play. And this is deliberately written in 6 different parts. It is for us to understand what we are doing and then do it. So first one, actually number 0, is the basics. This basics part is a playbook. The playbook is provided to us in the playbooks folder in that file. Now let's look at that file, what it does, understand it, and then implement it in our 3 machines. Or rather, this part gets implemented only on the manager machine because it says so. Host, only the manager. You see the inventory calls out and divides our list of machines into 2 parts. One of them is the manager machines. And this section begins with line number 1 all the way through line number 8. That section is for managers. And the rest below is the section for workers. So that's how you divide your inventory into 2 parts. You're able to call out managers and run a piece of code directly only on the managers. And in the manager, what I'm really doing is these tasks. And we'll understand these tasks and actually do it on the manager. But before we run, let's understand the big picture. What is this task? What are we doing? And why are we doing it? So as you know, I think when we started talking about containers, one of the first things that I think Jessica asked was, can I limit a container into a certain amount of memory, certain RAM, or certain CPU? Can I limit resource limits? Can I put some resource limits on a given container? Yes, you can. And in fact, to enable that capability, you need to make sure that you're modifying a specific kernel parameter. Kernel parameter needs to be modified. And that parameter is what we are modifying it in our line 26. What we are really doing is cgroup enable memory accounting and swap accounting. We are enabling it to be true. It says equal to 1. So cgroup enable memory accounting, and we are passing that in the line group command line Linux equal sign. We are looking for a regular expression called group command line Linux in the manager machine and passing this line as a line in file to set up kernel parameters for Docker on all the nodes. That's what we are really doing. We'll also notice that if you go to the machine directly, you will find that this line currently, what it currently contains, and then once we run this particular piece of code, what it actually contains, we'll then compare and contrast. But for right now, let's go to maybe one of the machines, like say manager, for example. So we'll say manager, what is your IP address? And we'll go find out the kernel parameter for this manager machine. And we will visit that machine, hey manager, can you please let me in? And it will say yes, and I'm in the manager now. Now in the manager, what I would like to do is find out what is the value of the parameter right now in a file called etc group, etc default group. In that file, we have group command line Linux equals console blank equals 0. That's the string that we find. Now we know from Debian documentation is that we need to modify this particular group parameter to let the kernel account for memory and swap accounting using C groups, the control group feature of Linux. That's what we need to make a change. You can see these details in Debian documentation about Docker, or any Linux documentation about Docker. This is not specific to Debian. So you have to make that parameter change and then make the machine reboot, load the kernel again, and that will allow for swap accounting parameters. So that's that action, line number 22, which begins with this line and ends in that line. That block of code will enable swap accounting. And this is, again, a critical thing to do in production, but not necessary when we are just playing around with some test setups or just learning. It's not critical. But production, you need to have controls. So you need to do these things. Next thing, what we are looking at is the action in line number 18 here. What we are really doing is updating all the packages to the latest version available. And we are saying, using the apt module, we are running this action on all the machines, and just make sure that this is set up. So I think what you can see is you can actually change this word manager to all. And when you do it on all the machines, you can see this action taken on every single machine. I think that should be actually all instead of just manager. I'm going to make that change right now and make it all. Because of what I want to do is set up swap space on every node also. If you look at this machine right now, for example, the one we are connected to, this machine, manager machine, and say, hey, manager machine, can you tell me how much swap do you have? So if you say df-h, you will find that there is no swap available, none. They don't give you. The reason, I think, is a business reason why some clouds, or rather most clouds, don't give you a swap file is business. It is good business for them. If they give you a swap file, then you don't need to spend more money on getting a machine with more RAM. And they want you to spend money. So you will be forced, if you don't know this, you will be typically inclined to go and get a bigger machine. So I'll go to Silicon Valley. If I find that I need more RAM, then I will need to get a bigger box. I think I just accidentally installed and created a machine for no reason. I need to delete that. So I'll delete. I just accidentally clicked. So I'll kill that machine later on. But what I was saying is you need to go to Silicon Valley and or go to some location and select an OS. And then you have to go grab a bigger box with more memory, like 4096, as opposed to only 2048 or only 1024. But if you're using swap meaning swap file, that is not strictly necessary. You can get away with a less amount of RAM, even if you need a little bit more RAM than is available, because swap will take care of it for most parts. For certain things, you absolutely have to have real memory. And so that is one of the reasons why most cloud companies don't give you a swap. And so you can set up swap. Nothing prevents you from setting up swap. So I am going to set up swap file using a script like that. And this, what it does, it gives you an 8 GB swap file on every box. And so that command is basically an idempotent way of creating a swap. It will run only one time. If it detects that there is a swap already, it will not do it. If it detects that there is no swap file, it will create a swap file for you and make the machine available with a swap file ready for use. 8 gigabytes is my size chosen, which is good enough, at least for our example purposes. You can bet bigger swap, or maybe get a machine with bigger RAM by spending more money. It's up to you, really up to you. But what I'm doing in this step is adding swap on every machine, all the nodes. Then what I'm doing is running ctop on every node. Ctop is kind of sort of like top, or if you have this thing called htop. Htop is not included in this particular, so we have to install it if you need to. But I think htop is here directly on the workstation. You have htop. Htop is basically a view into the performance of the machine. This is like a machine level performance metric, a tool for gathering machine metrics. Similarly, there is ctop, and this ctop is a tool to gather performance characteristics of containers. Now, this is where it will be useful to run inside a containerized environment. That's why I am installing ctop right there. And I'm using ctop script available in this location. The ctop script will install ctop on all the boxes. That's what I'm doing through that script. What I also want to do is upgrade packages on to the latest versions available and set up kernel parameters on all the Docker nodes so that cgroup will enable for memory and swap accounting. I want to enable that. And once I do that, I will then update group. This group thing has to be updated by running this command so that it picks up, and then a reboot. That's what is necessary. So I want to run these basics, and I will run it. I modified this segment, by the way. Just note that this was manager only before. I have changed it to all, like that. And I will do that change right now in the repository also, so that it doesn't cause you any trouble when you run it. So here is the playbook, and here is the basics, and the playbook needs to be edited to say manager, go become all, and then commit. So I have modified the repository also. So now we have it. This repository is now updated to show the playbook basics needs to run on all the nodes. Now, all. No, sorry. This was mistake. It was mine. I did not read it properly. I was wrong. I shouldn't have done that stupid change. This is actually just the manager, and the action all is here. I was being silly. Okay, I'll correct that. Oh, man. Oh, boy. Okay, manager. This needs to just run on the manager, because what I'm doing is the cron job. I want to run cron job only on the manager. That was it. So here, there's a division here. So if you draw a line here, in this line number 8, and there are two different segments here. One is the segment on top, which is just focused on the action to set up cron job capability for the cluster. You want to run periodic jobs on the entire cluster. You want to set up cron capability, and you want to specify what jobs need to run. And you want to run cron on just one box. The manager box is a good candidate. And that's why the segment above in lines number 1 through 7 are running only on the manager machine. And I mistook it to assume that it is running on the entire. And that's why I modified, but I reverted. And I think I reverted here also. Did I not revert on the, I think I reverted there also. And here is still all, and this is manager. So I think that was a mistake. I accidentally made an unnecessary change, so I reverted that. And this manager machine will run a cron job. The cron job is currently empty. Maybe there is a cleanup task, periodic cleanup. This is a periodic cleanup of Docker system to clean up unnecessary things that you might have. And that's what I have in that location, is to prune and put that entry in the cron tab file, so that every so often, I think it's every, I don't know what that clock is, but that cron clock, let's see what that clock does. We'll find out what that means. That has a meaning to it. I don't remember readily as to how to read that, but 08 should be every 8 hours or every 8 o'clock in the morning. I think that should be it. Every 8 o'clock in the morning, you clean up Let me just find out what that means. So go to cron tab, or rather cron tab guru, and they will tell you what that means. So here's the expression editor. We'll say star 8 star 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 star. Is that what it was? No, 0 8 star 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 star. So 0 8 and then star star star. How many? 3 stars. And so here is at 8 o'clock every morning. So at 8 o'clock every morning is what the Docker system will prune unnecessary things it doesn't need, like unused images, unneeded containers, things of that nature. Just a cleanup action. It will clean it up for you every morning, 8 o'clock. That's the command I have put as a example in the cron tab that I want to include and run it only on the manager. And then I run these tasks on all the machines that we have. So let's go run it now. Now that we have understood what this does, let's go run it. How do we run it? Running is fairly simple. What do? We say Ansible playbook and then the name of the play. As simple as that. So we'll go here and say Ansible playbook, and then name of the playbook is 0. So go run this. First of all, you will see that it runs the offending line. Oh, I see another mistake. I shouldn't be editing on the fly. I made that mistake by adding this dash 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 line in the playbook and saved it. I shouldn't have. Close it, back, and now run again. Now it will run. The idea behind setting up cron tab is to set up cron tab only on the manager, and you will see that that has already been successfully done. Now it is running in all playing it on all the machines. It is setting up swap space on all the boxes, each and every one of them, one at a time. Maybe it's not one at a time. It's simultaneously on all the boxes. So it should be about a minute or so on setting up swap space, because it is an action that involves formatting 8 gigabytes of space. So 8 GB space allocated as swap on every box, 1, 2, and 3. Then it is setting up CTOP on every node, the performance measuring tool, a monitoring tool, CTOP. Container performance monitoring tool is being set up right now. You will further see that it will go to upgrade the apt cache and then upgrade to the latest version of all the packages. That's what you will see happening. We have already picked up the latest version, so it should not take too much time in upgrading apt as such. But after this CTOP is set up, we should see the next action kicking up to upgrade apt. And then it should finish off the playbook after it sets up this kernel parameters for all the Docker nodes. Kernel parameters for Docker on all the nodes. That's what you will see. And then we need to reboot the boxes. So remember, we need to reboot. And you will see a nice method of rebooting boxes. I will show it to you pretty soon, as we are ready with this particular play finishing up. We should be taking about a minute more, and then we should be done with this particular play. So the apt upgrade is happening right now, and that should take in a minute, and then we should be able to reboot these boxes in a fancy way without having to go to these boxes and without going to the browser. Just on one command line, reboot everything. You will see that. And let's go search for it, what the command will be for that action. So what I'm doing is, using Ansible, I will be able to orchestrate across all the machines in my cloud in one command, and you will see how to do it. So the way to operate across a collection of machines that you have using Ansible is using the Ansible ad hoc commands. So you can run arbitrary commands in Ansible like that. So for example, there it is. So here is a command to run something in ad hoc. So we will go and understand what this does while our apt cache is getting updated. We will, what is this? Close. Okay. What I will have to do is, oh man, why is it coming up? Next, here, this is what I want to run and modify it. I'll say Ansible all my boxes. Please reboot. Like that. So you can arbitrarily run whatever you want with an ad hoc command, which is the -a option. And you can pass a string containing the command you have in mind, as simple as reboot, or as simple as whatever you like. And that is what the beauty of Ansible is. It lets you run arbitrarily anything you like on all the machines you have in your inventory with just simple step like this. So I will run this as soon as I'm ready to run and reboot all my boxes. As soon as the kernel parameters are set up and the group is updated, I have a response saying that it succeeded. And you can see that on the manager, there were 6 changes because there was one extra change of cron job on the manager. And on the worker 0, worker 1, there was only 5, not 6. So we have those changes showing up correctly. Now it is time to reboot all the boxes to take the kernel parameters take effect. And so I will, before I run the reboot, I'll just say echo, or just say host name. That should be a quick one to find out the name of these machines. So this command will go and grab the host name for each of these boxes. You saw that this command Ansible all ran the host name command in ad hoc fashion on all the boxes. First one gave this response, my name is manager. Second one gave this response, my name is worker 1. And third one says worker 0. You can arbitrarily run whatever you like. For example, show me the public, root/.ssh/authorized keys file that you might have. Authorized keys. Show me the authorized keys file that each one of you carry right now, and it would come back with my public key 1, 2, 3, 3 times. Here is the production manager. Here is the worker 0. Here is the worker 1. All of them have the same authorized key, which is my public key. And now I'm going to reboot these boxes. How do I reboot? Just change that command to reboot, not root, but reboot. And it will reboot these boxes 1, 2, and 3, and it will show fail. This failure is an indicator that it attempted to connect, it connected, it ran the reboot command, but then it was expecting a response from the machine, but then you had decided to reboot the machine. So the machine did not respond back. It just listened to the command, reboot, and it rebooted. And when it rebooted, it could not even respond back. Therefore, you get the error, is unable to fail to connect to the machine, because the machine started rebooting as soon as you said reboot. And so it did not even bother to respond, which is expected. So this machine is actually unreachable right now because it is rebooting right now, which is true. So you can now run another command to see if the machines are all back up and running. And that another ad hoc command you can run with another module. You can run the module in ad hoc. So I'm saying the -m option is to run a module called ping in ad hoc fashion and run this in all my machines. So this ping is different from the usual ping that you know. This ping is slightly different, as you will see. And this is not the classic ping that you know of. So here it is. It is going to ping the machines, and the machines, if they're active, they will respond back with a pong. So this machine says ping, the machine responds back with a pong. Ping, pong, like that. And so these machines are now up and running. They're responding. They rebooted successfully, which is what we wanted. We wanted to change the kernel parameters and reload the kernel, which required a reboot, and machines are ready with reboot. And I did not even go to the browser, did not even have to connect to these machines one at a time. I just ran Ansible all -a reboot like that and rebooted them. And then in a minute, I said Ansible all ping, and it was able to ping. This ping is different from the ping you know, which is ping yahoo.com. And this is a ping protocol ping, whereas this is Ansible ping. This ping is Ansible specific ping. It responds with a pong. It's like playing ping pong as opposed to this ping. That ping is different. It's the internet ping that you know of. So that's what we did quickly with the basics aspect of this playbook. Now we want to install some packages. Some packages that are necessary for me because I like these packages. So the packages that I need. And I'm going to reinstall it on all the boxes. And here is the list. I need these guys on all the boxes. So just get me these items loaded and ready on all the machines. Because I would like to have these things. What I would like to have is wget, git, vim, tree, htop, python pip. Just some of the things that I like. Sometimes I need them. And so make sure you update the cache and ensure that the state is present with these items. The items list is line number 12 and down. So when I run this particular play on all the machines, I will get my expected result back. What I'm expecting to see is when I run that particular play called packages play here in Ansible, I'll say Ansible playbook, as opposed to the previous time we ran was just the Ansible command as opposed to running a playbook. This is just the Ansible ad hoc command. And here I'm doing is a playbook invocation. I'm invoking the playbook number 1, or rather 1.packages.yaml. And in there, it will install a bunch of packages on all the machines in my cloud. I have only 3 right now, but it doesn't matter how many you have. It will do it concurrently on all the machines, collectively, without you having to worry about. You just specify your desire. It will make it happen for you. And you will run this Ansible again and again. It will maintain the desire for you, right? Maintain the state. I don't know why my video camera stopped working. I'm just quickly checking that while this thing is loading up. While this playbook is playing, I'm testing my video cameras to see what's going on there. I am bad today with keyboard. I accidentally started something else. I think it finished. So we'll deal with keyboard later, this camera later. Let's go stick to the next one. Next one is the idea that I mentioned before. It requires machines to communicate using a private IP address, which I should elaborate a little bit on. So I'll do that. What I will do is make sure that you understand this idea that these machines need to talk among themselves, not on the public network, but on the private network. And I chose to get a private network. But what I want to do in this particular playbook is I want to make sure that I am setting a block-in file. Now, this is something that let's go actually before I run this idea of block-in file with you. Let's go first of all understand what these machines currently have the capability of by visiting one of the machines. So we'll go to one of the boxes that we had visited before, like this one, for example, the manager machine. And here we'll say ifconfig, or rather IP address. And so we find that there is a local adapter, which is the local address for every machine, the local host address. And we find that there is this second adapter we have here, which I am expecting. It is the same IP address that we have for the machine itself. But then didn't we ask for a private network to this cloud? You see, when I said Vultr Cloud, you please give me a private network. Didn't I ask that? I think I did. And so I want to go delete this unnecessary instance, which is there. So I'm destroying it and say, yes, destroy that one. We don't need you. So go away. But this manager, didn't I create settings and say private network? Didn't I enable private network? Huh. Okay, apparently I did, but it did not. I'm expecting another IP address in the private network, and it says no private network. How is that? Okay, let me quickly check. I think I remember checking, creating private connection, which I wanted. And if I don't have it, I will have to create one.
I remember selecting that, yeah.
I know, I do. I exactly remember that when I created a machine, I asked for a private network, and it did not give me. So let's go examine the settings section, IPv6 firewall, customize or change host application. Snapshots, backups, DDoS. No, I don't have it. So what I will do is run that playbook, which should create another adapter, ENS7 adapter, and make that available to our machines. Like right now we have only ENS3 and localhost, 2 adapters. When I run this particular play to get a private IP, it should grant me a new adapter by this name, ENS7, on all the hosts. That's what I'm expecting to happen in this particular piece of code. So let's go play it. I'll revisit that code and explain it to you. But for right now, what I'm doing is running that play. So the play I want to run is number 2, that one. So it should create a new adapter called ENS7 and make it available in all the machines. Let's go. Let's go. I want to show it to you before I run it, because it should work. What I want to show you is the thing that is missing, right? So if you go here and say cat etc networking interfaces, in here, what do we have? Nothing. And what I'm trying to create in there is actually a file for another interface, like here at C network interfaces. In that location, we should have another interface created. Currently, it should not exist. So if you go up a level and find out this particular file, what it contains, cat interfaces, you will have the local adapter and ENS3 adapter, right? We don't have another adapter already, which Vulture Cloud should have given us. It did not. However, this playbook should take care of that. It should create a new interface called ENS7 and assign it an IP address from the cloud, and it will become the internal network. So let's go see what it actually does in this particular file, which is the file called net interfaces file in the etc network folder. So remember that's what you saw. It had only localhost and ENS3, no ENS7 yet. With that understood, now I will run the play. Play is playbooks number 2, private IP, and I'll run that play. And this play, what it does, as you can see, is it sets up some debugging. I think this is debug steps, and this is specific to, which cloud is this? Yeah, ENS7. So it's Vulture Cloud specific. It is actually debugging and putting some outputs here. We should see those outputs coming up, and we have an error saying cannot find device ENS7, which means I think this is a problem that we are running into with Vulture Cloud. We should go back to the cloud and find out why you're not giving me that particular adapter which I asked for it. So let's go to that cloud again. In the server, manager 0, we should be able to ask for our settings in a network section. Say another IPv address. No, not this. I want to get a private network. And in here, I want to add a network. No. Let me create these machines one more time and see what if I'm forgetting something or what. So Silicon Valley Then I go to Debian, and then I select this machine, and then I selected private networking, and I did not apparently add a new private network. That's what I think I missed. So we can add it now. I think I created enable private networking and attach the chosen private networks below to this VM. So I had to go, and I think I forgot this button to create a private network. So I need to create that network and then attach it later. So no worries. What I will do is, let me recap the mistake I did. Apparently I have caught my mistake. When I was creating that machine in Silicon Valley, and I selected Debian, and I selected this machine size, then I selected private networking, and I should have added a new network like that. Let's put that in our Silicon Valley area and assign it some description and give it a subnet that matches what we have in mind. So the subnet we have in mind, I think, is 1099.0. So we'll grab that subnet, and 1099.0.0/24. That's the subnet I think I should have added in my private network. And you add that network. Now, once you have that added network available, this private network in that address space, we should now go back to our instances and make sure that these machines, like manager settings, and you attach them to the private network and say yes, and do the same with the other two boxes. So I just attached my private network to this manager machine. I will do the same to the other two boxes and get them to configure each other and become a part of this private area network that I'm creating. You can do the same thing in any cloud, by the way. You've seen it in Amazon cloud as an elaborate example. And now I am showing you the same thing in this cloud. So we have, this machine is currently rebooting. It is currently stopped. We should go do the same thing in worker 0. And we go to the settings area and attach this to the same network and say, okay, and do the same for the third machine. Go to the settings area and attach to the same network and say, okay. And then we go back to the servers, and we should see that they're all running already. How come? How so quick? I don't believe this web interface. I thought they were stopped and so quickly came back. It's unbelievable. But we'll go back and check with our Ansible configuration. Are you really active? How do you check? You say Ansible ping. Are you really alive? And no, it is not. They were lying to me. See, it is not alive. I did not believe that web browser interface. The machines are not alive. One of them is still working and rebooting. So we'll wait for them to come back up. And once they all ping pong respond successfully, we should then run our play to get a private IP address. And this time it should work, and it did work. So bottom line, I did forget a piece when I was creating. The piece that I forgot was to actually not only enable private networking, but also add a private network. That piece was missing in my action. So I was able to come around, work around, and attach these three machines on a private network after the fact. As a consequence, we now have these adapters included, and I should be able to examine these adapters directly if I go to the machine. And there I say cd etc network, and then cat interfaces, and you should see that ENS7 shows up right there. ENS7 shows up as a static IP assigned. It is written in this particular file by Ansible. The file before had only this segment. Now the file includes the segment below. in between these two lines, and Ansible managed block, Ansible managed block, in between that, we have added this particular segment into that file. This action we just saw happening is called a block in file action. Block in file. And that's the thing that I wanted to talk about to begin with, which is we are just like line in file idea. You insert, modify based on a regular expression, you append, modify, edit, delete, whatever you want to a line in a file. Similarly, this idea is block in file. It's like a collection of lines together, a block of lines together in a file. What I want to do is insert and update the ENS7 configuration stanza in the Etsy network interfaces file. So I am telling block in file as the module in Ansible to go to look at that path and make sure that this block is present. And this block basically is that block, which you saw is included in that file. And you will see that this is the block. You will compare it item by item, you will see what we did. And here it is on one half and the atom editor on the other half. And you will see exactly what we did. And there are subtle changes. The only change you will see is this last octet here. This number 90 is generated number. It is unique to every machine that we have. So it is a generated number called last octet, and that is assigned to be 90 for this machine. If you go to other machines, you will find that number 90 will be different, which needs to be different for every machine. So for manager, I'm just choosing the last octet 90. For worker 0, you will see the last octet 185. So let's go to that worker 0 and connect to it. So SSH root at worker 0. And you will go to that location called cdhc network and then cat interfaces, and you will see 185 right there. And that is the action that you see coming from this particular Ansible block in file. We are placing this block of code inside that file called interfaces in a folder called Etsy network. And that is what this action does. So as a consequence, what we can now do is, this machine is, which machine is this? Worker 0, right? Worker 0. So on this machine, we can just ping the machine called 1099.0.90. There we go. We are pinging, and we are pinging through the back door, internal door, I should say, not back door, internal network. We are pinging the other machine internally. So see that ping coming from worker 0 going to this number 90 is the ping going to the master manager. And that action, that traffic is traversing through the private network. That's the critical action you need to do. You don't want to be having these machines talk to each other on the public interface network, the public IP network. You don't want them to be talking secrets on the public network. That is a very important thing to remember. Our documentation for Docker doesn't talk about that. You will see this page will not describe that detail to you at all. They describe configuration, they'll talk about networking, but they will not describe the subtlety here that you want to make sure that the communication that needs to happen in between machines needs to happen on the private area. Well, we did that. Now that that action is done, we know that these machines can talk to each other on the private segment using this particular playbook that we have, which is called private IP YAML. And the playbook itself is very simple. It's just one block in file construct, which is this action called block in file. Everything else before is, half of that is debugging, and the other half is setting some fact. This fact setting is like gather fact action to get the fact, get the default IP address. We are basically trying to calculate the last octet. What do we assign as the last octet in that subnet? And for that, I need to gather last octet from a set fact from the public IP split action, which can be cryptic, but this is Python language. If you know Python, you will understand it. If you don't understand Python, then learn Python. There is no other way out. You have to learn Python to get to Ansible, because Ansible is Pythonic. Chef is Ruby language. And so you need to learn Python if you're doing with Ansible. That there is no shortcut, there is no way around it. You don't have to be like expert in super duper Python programming, but bare minimum enough. Just there is this idea that I should mention. You don't need to be a Ruby programmer to do Chef. So you don't need to be a Python programmer to use Ansible, but you need to know Python. Doesn't mean that you become a Ruby or Python programmer. All it means is that you need to know just enough language, just enough Python, just enough Ruby. You need to know these things. This is like speaking English mostly. In fact, there is a page, just enough Ruby for Chef. And it is actually a part of the Chef documentation. So this is like one page of Ruby that you need to know, Ruby basics, and that's it. This one page, this is all the Ruby you need to know to use Chef. That's it. Similarly, there's a page like that, just enough Python for Ansible. There should be a page like that, I'm guessing. Maybe not. There isn't a page like that. No, I could not find it. I was expecting a page like that, but no, it doesn't. But bottom line is, here is another, just enough Scala for Spark. There is, Spark is based on Scala language. So you learn just enough Scala to use Spark. That's how I think most of these tools are focusing on just enough for you to get to use the tool. You don't need to become a Python programmer, but you just need to know Python. That's what I think I wanted to communicate that to you, which I think you got the idea. So these things are Pythonic. They come from Python language, and I'm trying to calculate the last octet and setting that here so that I can actually get a block constructed and embedded into that file so that my private IP networking is possible. This thing is a whole lot easier to do in other clouds. This is probably the most difficult one because they don't do it for you. You have to actually manually assign these kind of blocks inside this file. Other cloud will just give it to you by default. And we should see that. You already saw in Amazon. You should see in other clouds, the moment you get a public cloud, private cloud setup, the moment you get a public subnet, private subnet setup, it will automatically assign a private IP, public IP. You've seen it in Amazon and other clouds, Google Cloud, they do the same thing. And they just do the whole way, all the way to even including this interfaces file and this particular block in the right spot is already done for you. You don't have to worry about this particular playbook, this private IP playbook. It is probably necessary. I don't know why they don't do it in Vulture Cloud, but most clouds will already do it. So you don't have to worry about this piece, by the way. That's what I'm saying. Having said, I will close this action, go to the next action. And here is what I want to do is what I did here already. What I did was ping this machine, but I don't need to remember that number. It is so hard to remember these numbers. So what do? I need to actually be able to do something like ping manager 0 like that. And it should ping. It doesn't know what manager 0 means. So ping worker 1, it should, but it doesn't know. All it knows is its own name, ping worker 0. That it knows. It is pinging itself. That's fine. But I would like it to ping other people. It doesn't have an idea about who these guys are because etc host file is empty. It doesn't have an entry there. So I would like to make an entry, just like there is an entry for worker 0 and worker 0 again in IPv6 and worker 0 and IPv4. Those two entries are there in etc hosts. That file contains those entries. I would like to have the entry for worker 1 and manager also in the same file in every machine across all the machines in my cluster. We just have 3 right now, but I want to have it for all. Everybody needs to have it. So how do you do it in Ansible? That's what we will be doing next. So that I can just ping worker 1 or ping manager by the name, call people by their names, not their social security numbers. And that's what, or rather IP addresses. IP addresses. So host file. See what it does. There is an action. Action is template action. And what I'm doing, I am basically creating a new etc host file, destination etc hosts. And I'm creating that host file using a template. The template I have placed in the source folder is /etc host j2, Jinja 2 template. This is the Jinja 2 templating language I mentioned a little bit ago, a couple of days ago. And you can see that this source file is actually sitting in that location, etc hosts. And this is kind of sort of the structure that we have already for our host file here. It already matches to some extent. But again, what you look at the left side is a template. And what you look at the right side is the actual file. And what I want to do is compare what we have with what we should have. What we should have is on the left side here. And what we have is these 2 lines plus some more, yeah, these lines. That's what we have. But what I need to have is on the left side. So take this template, apply it to every machine in my cloud, in my cluster. And while doing that, adjust an account for the fact that every machine, worker 0, needs to know about worker 1, 2, 3, 4, 5, all of them, and managers 1, 2, 3, 4, 5, all of them, and any number of them. I just need to have this particular file in every machine, account for all other machines so that they will talk to each other by names. And that is done through an Ansible managed block. So here, Ansible managed is the block that we are starting to write. It begins with line number 10. And it's a for loop. A for loop as in 4 items in playhosts. So it will do the same thing for all the items in the list of inventory that you have. For item in playhosts, repeat this action up to the endpoint. The end of for loop, this is the beginning of for loop. Line number 11 and 12 are the items inside the loop. And you repeat this action any number of times needed. And that number is dictated by the items in playhosts. How many hosts we have? 3. So this action number 11 and 12 will be repeated 3 times. Rest of these things will be same. The rest of these things are actually the same or almost similar, slight variations. But these lines, 127.0.0.1 worker 0 and : 1 worker 0 are the ones for worker 0. I would like to actually get a short name set for items split with a dot, and that action will lead us to that action will, I think I need to do not disturb me. Okay. And this short name action that we have will grab the worker 0. This is the short name for guest, and guest.guest is the full name, and guest is the short name. So what you're looking at is the short name part showing up, and that you can do with a split at the dot. So this guest.guest, if you split that, this part is the short name for a machine. I'll give you a couple more examples to help you understand what this thing is if you're not familiar with it. And that idea would be something like, let me just go to this terminal. So go here maybe, and here you will find cat etc hosts, and you will find that there is this machine called iMac. It has a short name called iMac. It has a full name called imac.cloudgenie.us. That is a machine in my home, and it has an IP address of 10.0.1.4. If you look at this machine, the one we are dealing with right now, that machine is localhost. It has an actual IP address of 10.0.1.11, and the machine is called Pro. The machine name is showing up right here, Pro. And this is the full name of the machine, fully qualified domain name. And this machine name is the short name. That's what you will see for other examples. Cosmos, cosmos.cloudgenius is the actual machine sitting in over there in the garage. This is this is my private cloud in there, so I call it Cosmos. And there is a bunch of other machines. So by the way, short names and full names, that's what we are really getting after. And the line number 11 will set a short name and assign an IP address from the Ansible ENS7, meaning it will grab the private IP address like here, that address for every machine. So it comes from ENS7, the adapter we created already in our Ansible play early on. The adapter is called out here in network and ED. So I should say just cat etc network interfaces, and that ENS7 is going to give us the 10.99.0.185 kind of the internal address. That address is available from here as that Ansible variable. This expression is evaluated from your expression evaluation happens in the examples that you saw here, gather facts. That's how it's able to gather facts about the machine, and it is able to detect what the value that needs to go in this template will be placed in the destination, and the template itself is sitting in a different file here, and that file is evaluating the Ansible ENS7 IPv4 address and assigning the entry for the item and the item's short name, both. And so as a consequence, you will see a new etc host file created in all the machines once you have this playbook executed. So right now you see the machines have a playbook that looks like this. It looks like this. Now I will come out of that machine and then run the play, and you will see the new scenario taking effect, in which you will find that machines will be able to talk to each other by their names. So let's go see that. Ansible playbook, and then play the Ansible play for number 3, which is hostfile.yaml, that number 3, this file. And what we are really doing is placing etc hosts a new file using a template. And let's see that in action. The action will result in these machines talking to each other by name. And so the action will finish off very quickly, and it generates our host files, and then we have action completed. We should now connect to one of the machines and see what we have as our etc host file. And now what do you see? What do we see here? We see this new block is the Ansible managed block. It has the private IPs 1, 2, and 3 called out for the 3 machines. They are production worker 0, production worker 1, and production manager 0. So now we know these machines by their names. We can actually ping production worker 1 from worker 0, and it should respond. See, I'm on worker 0. I pinged worker 1 by its name, and it responded. Same thing. I'm on worker 0. I'm going to ping manager, production manager, and it responds. I'm expected, this is expected because you have actually modified your etc host configuration file just like that. And that is what you expect to happen, because this is, by the way, is a necessary condition in any kind of a cluster. So you have to, have a cluster of machines like that, and some worker machines like that. They need to know each other by name so that they can communicate properly, like that. And so that inter-machine communication, even like this. And so it's many-to-many kind of communication needs to happen successfully. And that will happen only if you have such a structure in your etc host file that allows identification not just by social security number, or rather IP addresses, but actually machine names. That is a necessary condition. That's why we have that play there. And once we have that play, we should now look at what this action is. This action is strictly not necessary to begin with. It is more of an application specific action. You need to create some things and create some folders and share some files. So we'll get back to this particular play later when we are actually ready to deploy a particular book, or rather a particular application inside a given containerized setup. So I'll skip that folder YAML for right now. And I'll move on to the next action. This action installs Docker on every node and then enables experimentation. So this is something that is not strictly necessary, but I'm doing it. And I am enabling experimentation mode for Docker so I can further examine. And so I'm setting this experimentation mode by setting a JSON expression in the daemon JSON file in the etc Docker folder by adding a line in file that begins with experimental : true. That's a JSON expression I'm going to include in the daemon JSON and then restart Docker. That's what I'm really doing, is not only installing Docker, but also enabling Docker experimental mode. Again, experimentation is not strictly necessary, but I like it, so I'm doing it. So I'll go back out here on the machine and say Ansible play, Ansible playbook, and run the play called number 5. And so what this will do is install Docker on every node, enable Ansible experimentation mode, and then tell me that it did. And then I will be able to set up Docker Swarm. And you know what Docker Swarm setting up action is expected to do. What it does, you remember and recall, which is the machine number 1, the manager, will generate a secret. And it will pass on that secret, the Ansible will pass on that secret to other machines. And then these machines will actually go and connect using the secret. And they will then become one big family. And that is what we will do in the next action. The next action, this action we just did was Docker. So Docker is now running. But again, at this moment, if you are able to connect to one of the machines, like for example, this one, you will see that this machine now has Docker. But it doesn't know about the other 2 machines and cannot configure and play in a particular container across multiple machines. It cannot do that because it is not really connected like a Docker swarm. That exchange of secret has not yet happened. So we'll make that happen. How do we make that happen? That's the last play. That is play number 6. That play is the most complex play you will see. And so it is hard to understand. And I understand that it is hard to understand. So I'm going to walk you through very specifically and step by step. I think this is, kind of cryptic. If you're not used to Python, not used to Ansible, it is cryptic to understand. But you have to learn it at some point. So why not now? That's how I think about it. So let's dissect this thing into pieces. By the way, this action that is written in this particular play is written in a fashion that it will determine the status and classify these machines into two different kind of groups. The grouping that we have here is to detect whether a particular machine is already in the swarm or not. That's the kind of detection is going on in the first few steps. And then later on, you will find that if a particular machine is not in a swarm, it will then make it join the swarm, or if it is a manager, it will generate a token and things of that nature. You will see that. When there are multiple managers, by the way, like I mentioned here, there can be a situation where you have multiple managers. Like that situation is also possible. So I should clarify that piece, is that this secret is a join secret, or rather I should say it is a secret to join as worker. There is another secret to join as manager. And so that secret is a separate secret. It should be given only to the machines that are supposed to be joining as managers. So you need to decide which machines that you want them to be joining as managers, and have these machines also join collectively as a group of managers as opposed to workhorses, and then use that different secret. Just want you to be aware of the fact that there are two types of secrets. One to make a machine join as a manager, another to join as a worker. So now let's go read this top down first, understand what is going to happen, and then see it in action live. And as a result, we will have a Docker swarm ready. You can see that here in this action, Docker, in this action here, for example, Docker swarm. Oh, come on, mouse. It's not responding to my mouse. How about this mouse? No. What? Cancel, close tab, quit, open. And let us read. I think it's easier to read this long file in the browser window as opposed to reading in this small window I have here. So we will go to the browser window. The window here in GitHub has the playbook called swarm number 6, swarm number 6. I think this place is easier to read, at least for you to read from a distance through this video conferencing interface. So what I will do now is use this browser interface to look at that, and let's go start reading this. So here, the first thing is to determine the status of each manager node and then break them into two groups. The groups are, so the concept is like this. So the goal is we have some machines here, 1, 2, 3, say for example. These are manager machines. And we have to decide whether these managers are already managers or not yet managers. If they're already managers, in that case, we'll use the swarm manager operational. Swarm is running an active classification. So it's the operational. And we had nothing to do, or rather nothing much to do. Whereas here, it is not a manager already. We want it to become a manager, but it is not a manager already. And so we have to bootstrap. Rather, I should use the word bootstrap, or maybe make it operational. That's the easier way to understand. If it is not operational, then you make it operational. And then it becomes operational as a consequence. So this classification is the first action we are doing. Yes versus no. Is it operational or not? That's the first classification. So determine the status of each manager node and break into two parts. Collection of machines, you have M0, 1, 2, 3, any number of them. You divide them into two parts. You run this action only on the manager machines. You become true means you get the super user privileges. So escalate your privileges. And then you run a task. The first task you want to run is to determine the swarm status. How do you determine the swarm status? You simply run this command docker info. That's it. It'll tell you whether swarm is active or not. You can run that command right here in the command line on any one of the machines. It will tell you whether swarm is active. So we'll go there and say docker info and check whether swarm is active. It will tell you it is not because we haven't activated it yet. And so swarm inactive. That's expected. We haven't done anything yet. So all these machines we have the same result, even though it is worker and not a manager, but still we haven't actually done anything. All we did was install Docker. So the swarm is inactive on all these machines. And that's what we are really detecting for in this location. Docker info, you grep for swarm and you cut d pipe dash dash. This is shell scripting. If you know shell scripting, then you understand it. But yeah, maybe you do. But I don't need to claim, I don't mean to claim that I know shell scripting. So what I do is I do Google. That's exactly how I work. Don't think that, if you Google something to find out how it works, that you're a bad person. That's not how life is. In real life, the internet is our textbook. This is how we learn. So if you don't know something, you Google it. You may have seen this, you may have seen me doing it all the time. When I don't know anything, I just go Google. That is exactly how you should behave in real life. I think you already do. But just saying that if you don't know something, Google. That's the best way to find the answer today. It might change tomorrow. Who knows? But Docker info, what we are really trying to do is grep that particular item out, swarm inactive. And using that information on every machine, we are classifying it and returning the swarm status in registering it. So we know whether the swarm is active or not based on this register. Now this register action is an Ansible specific action. It keeps track of whether the action registered a swarm status or not. And depending on the output of this action, you can then tell whether swarm is active or not. Ansible can tell whether swarm is active or not. That's the first step here. Next, we want to create groups. A group that I want to create, a group of machines that are called Swarm Manager Operational. Swarm is already running group. That group will be created by adding hostname to the group. Which hostname? When active is in the host variables swarm status standard outlines. So we have captured this register already, right? This register that we captured actually keeps track of the output of this command. Let's go run that command right here on the command line here. And we'll run, you saw this swarm active right there, right? We now run this specific command. We ran Docker info first. We saw Docker swarm inactive. And now we are going to run this command. What this command outputs is just focused only on the word swarm. It will tell us whether it is active or not. And let's go find out. It says inactive because we are actually cutting the entry corresponding to the line beginning with the word swarm in the output from Docker info to get to the point active or inactive. That's what we captured from that particular shell command to cut the portion that we expected to receive from Docker info. And then we grep it to look for the starting word swarm. And we know the cut output is inactive. That's how we are capturing it and storing it in that expression, swarm status. So when we have that swarm status standard outlines is the output that you receive here, which is inactive to begin with. When active is in the standard out swarm status, then you add this host name in the group called operational. So to begin with, every machine will be skipped because none of them have swarm operational. So this portion will be skipped as we go through the collection of all the managers. We have only one manager in our example. So it will be run only once, by the way. The run once, true. So this action is run only once. Next, once on every manager. So it's a manager specific action. It is going to be run on every manager, run only once. And when you find a manager is active like that, then you put that particular host name in a group called swarm manager operational. What we are really effectively doing is dividing them into this group. The group where the swarm is already operational versus this other group where it is make it operational or not yet operational. So bootstrap it to make it operational like that. And that's the second group, which is the bootstrap group. So here, create swarm bootstrap manager. Sorry. Say again. Create swarm manager bootstrap group. We have to create a group which needs to be bootstrapped, which needs to be make it operational, which needs to be, we have to make it operational as a swarm. So that will basically do the same thing. You look at the host name and add it to the group called swarm manager bootstrap. These machines need to be started into the swarm. Not machine starting, but machine incorporated into a swarm setup. So that action will happen when active is not in the swarm status. You saw the swarm status here, active versus inactive. So when active is not versus active is in, not in. That's the difference. And that's how we are dividing the machines, the manager machines we have here into two parts. 1, 2. Operational, not operational. That's the first set of actions that we were able to now understand is what these things do. So check the status of swarm and then divide into two parts, operational and not operational, or rather bootstrap. Needs to be made operational, not yet operational, bootstrap. So that's the action here. Next, we do the same exact thing with our worker machines. Again, same thing. Determine the status of each worker node and break them into two groups. Swarm worker operational and swarm worker bootstrap. Same idea here. Do this on workers. Any number of them, you divide them into already operational and make them operational. Meaning not yet operational. Not yet operational. Or that's what we are calling it, bootstrap these guys so that they become operational. And so that's how you're classifying these worker machines also. And you will do the same thing. You look at that flag. The flag is coming from Docker info. Here, this flag, currently inactive. And you use that flag to divide. And you would see that action happening here. Host, you run it on all the worker machines, escalate privileges. Then the task is to determine swarm status. Is Docker Swarm active? Get information from Docker Swarm command on the command line and grep for swarm and cut. When you cut, you get active or inactive based on Docker Swarm info. And use that to register the swarm status of every machine in the worker collection. Once you have that status in hand, use that status like here to decide when active, put that group, put that host name in the operational group here. Put that item in the operational group. And same thing again this time when active is not in the swarm status. When it is not active, you put that host name in the bootstrap group. You're basically classifying the two collection of machines the same way, not much different. And now comes the operative part, the action part, the bootstrap action. This action is when the swarm manager operational group is empty, meaning there is nothing that is running swarm. We need to initialize one of the hosts and then add it to the swarm manager operational group. Like initially, first time, nothing is running in Swarm. And so you want to look at one of the Swarm Manager bootstrap machines that are ready to be bootstrapped, like one of them, like the item number 0 in that group, and say initialize the Swarm cluster. And when you say initialize Swarm cluster, you have to actually run the initialize command. Just by giving it a name doesn't do it. You have to run this command like that. Docker swarm init. And this command actually generates a token, the secret, like I mentioned before. Like these secrets, they will generate that initialization time. This machine will generate a secret, and we will keep track of that secret. Ansible will keep track of that secret and give it to these guys so that they can join, and it will make them join also. That's the initialization step, which is basically advertising an advertise address. So what I'm doing here is you use the ENS7 internal Ethernet adapter so that your communication of generation of this output that you're receiving from Docker Swarm init is done and exposed on ENS7, not ENS3. The ENS3 is a public facing network card. This one is the internal facing network card in Virtual Cloud. So what you will see here is when the Docker Swarm gets initialized, you will have to register this flag. You're doing it the first time, and so you're registering this flag bootstrap first node. So you're doing it first time, you know it that you did it. Now when you did that, what you will see is this action needs to happen when Swarm Manager operational is not in any group, meaning the group doesn't exist, it's empty. When the Swarm Manager group is empty, that's what this when condition is. When there is nobody who is actually running a Swarm Manager, that is the first time you want to bootstrap the first node and say Docker Swarm initialize, and you grab the tell Docker Swarm to advertise itself on the private network at this particular port number. These are standard ports used by Docker, 2377 for inter-machine communication. And this is the adapter that you want to call out by specific name so that it advertises itself on the private network, not on the public network. Having done this part, we'll see what next action is. The next action is to add initialized host to the Swarm Manager operational group. Since we just initialized Docker Swarm, we know that first host that we have needs to be made operational. It needs to become a member of the operational group. So we did that. We said add host name called the item, whatever that item that we're dealing with. This item, bootstrap 0 item, becomes a member of the Swarm Manager operational group when bootstrapping first node. When we bootstrap this first node, at that time you do this. You add that item to the Swarm Manager operational group. Next, what I want to do is to grab the token that it generates and I populate a list of IPs listening on that port. So the token that generates will become available, and you can actually see these actions. So we'll see them. When we see it live, you will see them happening. So the next action here is hosts. We want to focus on Swarm Manager that are operational on the item number 0 in their group, meaning this item that we already initialized the Docker Swarm on that same machine. It is now a part of the manager operational group, and the machine number 0 in that is the same machine where we initialized Docker Swarm. And so in that machine, once we initialize Docker Swarm, we know that we can retrieve the token. The token can be retrieved by running this command like that. So get me the manager token, please. This is like getting the manager token output. This command will generate a manager token and dump it. And we save it in that register. So Swarm Manager token is saved right there. We'll also retrieve the Swarm join token for our joining as a worker and save that token, the secret token, in the Swarm worker token register. So registering that token and registering these two tokens as a manager and a worker, both tokens registered. Then we populate a list of IPs of managers. These IP addresses for managers, we group them in Swarm Manager IPs, and we are basically grabbing the IPv4 address for the items of all the machines that are the operational group as managers. So we know these manager IPs. Next action is to join the manager hosts not yet initialized to the Swarm cluster. So there are certain machines that are not yet initialized, not yet become a member. They are basically ready to be bootstrapped, and they are not operational. If that is the case, then they're not operational and they're ready to be bootstrapped. What do? You will bootstrap them. You will get them the manager token, this work manager join token, not this, but that token. You give them that token, manager token, and have the machine join as a manager. So that's what I'm doing here, is saying that when the machine Swarm manager is ready to be bootstrapped, but is not operational, in that case, you grab the token. The token you want to grab is the Swarm manager token, and expose that in form of a token variable. And you use that token here in the Docker Swarm join command. The command before was Docker Swarm initialize command. Whereas the command right now we are dealing with, when a new manager wants to join Docker Swarm, you will be able to detect that it's a manager that is ready to be bootstrapped, not operational already, and ready to be bootstrapped. In that situation, you have the machine Docker Swarm join using the token and go to the IP address that we have saved already for Docker Swarm managers and go to that port number 2377 where the manager listens. And you also start advertising as on the private network as one of the managers, so that you start advertising. You are now a manager also, and you will go join the Docker Swarm. That's how you will join the manager hosts that are not yet in the Swarm cluster. Now, in our example, we just have one manager in our example, so you will not see this actually kicking in because we don't have two managers, we just have one. But we have two workers, so you will see this action kicking in. You will see that Swarm worker bootstrap action, and you will see that the token used for this action is the Swarm worker token. And we will use that token here in the Swarm join action, Docker Swarm join, using this token, which is the worker token. So it's not a manager token, but a worker token. And you join workers to the cluster. So now you say Docker Swarm join, advertise address again to be the ENS7, private IP address 2377 port to go advertise yourself on, and you use the token that you have from the worker token, and you join the manager's IP. That's what you will see. So now let's go play it. Any questions in the meanwhile are welcome anytime. I know this is cryptic. This is first time it is cryptic to understand, but I am basically giving you the idea that you can use this tool to configure a Docker Swarm for your own needs. Most of the time, it is very likely that you will use a ready-made solution like I do. I don't set up Docker Swarm like this. I've told you that I use a ready-made solution. I use a Kubernetes ready-made here in Google Cloud, which is what most people do. They just go do a ready-made solution and use it. Nothing wrong with doing that approach. But again, we are here to learn. And so we will learn how to do it. We learn the hard way. So what we are dealing with is the hard way. We'll also do the same exact exercise of doing the hard way, Kubernetes the hard way. It is really, really hard. And there is an exercise for that. It is called, it has the name Kubernetes the hard way. It's going to be coming up in 3 days from now. Kubernetes the hard way. There is a famous exercise, really famous, like about 1,500, 1,300 people have done it. So that's that exercise. There are that many folks. There are 9,000 stars and lots of people watching and all that. It's a very popular exercise that people do to really understand what does it take to set up your own Kubernetes cluster, and what does it take to set up your own Swarm cluster, which is this exercise. So I'm going to do this the Ansible way. It is not really hard way, because the hard way is this way, is the hard way. Actually no automation, completely hands-on, item by item. You have to really pay attention to what you're doing, and you make sure you don't make any mistakes. Otherwise you will not have a ready product. So that's how you learn the hard way. So we'll do the hard way stuff also. But practically speaking, when you go and actually use something, you will probably use a ready-made solution like I do here, like that. But right now we are learning how to set up Swarm using Ansible. So we'll play number 6, and you will see that it does exactly what we expect. So we are ready to run it. And Ansible playbook, and playbook number 6, and you want to run it step by step, you can go that way. If you want to run directly, you can go there. Either way, you tell me what you want and we go that way. Step by step or no step by step? Let's go run without it. So just run it and see how quickly it finishes. It'll gather facts on the first machine. It sets up Swarm, it determines Swarm status, then gather facts again and finds out that it is not a Swarm. So then it initializes a Swarm, or rather here, initializes a Swarm cluster right there. And then it is almost done. Where is that? Initializing Swarm cluster, initialized host, one of the hosts to manager to become a manager. And then this production manager 0 became the manager. It retrieved the Swarm manager token, retrieved the worker token, populate list of manager IPs, and then it find that there is no machine that is ready to be bootstrapped and not operational yet. So it skipped that operation as I told you before. And then it had to set up the worker to bootstrap. So it gathers facts and joins the workers to the cluster, production worker 0, worker 1. And now we have a Swarm. What does it mean? We have a Swarm. So we should go to the Swarm. We should go to the manager machine and find out what do we have. So we'll first go to the inventory, find out the IP address of the manager and see what do we get. So SSH to the manager. And now we say Docker info. What do we see now in the Swarm status is active. And you can see that this Swarm is actually telling you that it is actually the manager machine. This star is the machine where you're working on. The manager is the host name. It is active and available. It is also the leader. It is running as our Docker version 18.04. And the Swarm is active, which means we can now interface with Docker Swarm and it will run across a bunch of machines that we have, like worker 0, worker 1, and all these guys. So that's the scenario. But now I would like to play with it with actual workload, right? I want to put some work on it. So I will deploy some work. How do we begin? We have to, let me read this, if there are some actions here. Yeah, I think we should be able to read this README and see what it does. Some services, traffic, visualizer. Okay, we should be able to run some example applications on the cluster that we have created. and see what it does for us and see what it means. So once I run these things for real, you will get a clear idea about what that cluster is really doing for us. And I hope to do that in a fashion that will help you understand. So what we have done up until now is we have these 3 machines put together in form of a cluster. We need to go talk to the manager and ask it to do some stuff for us, right? And it will do whatever we assign, whatever actions we assign. It will automatically balance and distribute the work among workers, and all that action you will see it happening. Now, what I want to be able to do is I want to run multiple applications here and all that. And what I want to be able to interface to those through some kind of a proxy. Now, what is a proxy? That is something I want you to understand. So a proxy server is something that, or rather I should say a reverse proxy. I would like to have a reverse proxy there. So the reverse proxy will be something that my users will ask for. Hey, can I go to, say, CNN.com? And this CNN.com seems to be running here, say, for example, here. And so this reverse proxy, when you go ask for CNN.com, it will know automatically that you are looking for CNN.com, and it happens to be running in that container there. So it will automatically connect you and send your traffic to that container. When another user comes in and says, I want to go to foxnews.com, and this happens to be running somewhere in maybe here. And so this reverse proxy will already figure out that you are looking for Fox News, so it will send you exactly there. And as a consequence, you will see Fox News. So you can run a bunch of things wherever you like, and they will run within your cluster, and your reverse proxy will be able to understand incoming traffic and appropriately route your traffic to a variety of services. So in your company, for example, you have, I don't know what you have internally, but you have a large cluster, and you have a bunch of different applications running, and you have your customers coming in, asking for, say, give me xyz.boeing.com. Then your reverse proxy should be able to handle that request and identify that this user wants to go to XYZ. So XYZ happens to be running here. So you just route the traffic to that destination where XYZ runs, and then this customer is happy. Another customer comes along and says, I want abc.boeing.com, and you just deal with the same way. The reverse proxy will decide that this happens to be running right here. So boom, you go connect and make that user happy. That's the whole point of this reverse proxy business. Have you used such a reverse proxy ever before? Anybody?
Yeah, I used.
Okay, so this reverse proxy, that we have a ton of them available out there. One of the most common ones is this, Nginx reverse proxy. Another newer reverse proxy that I want to use, I think today, is open source, and it is called the traffic reverse proxy. This is a new reverse proxy. What this does, as you can see in this picture, is that if you have a Docker Swarm mode, Kubernetes, any of these orchestrators, what it will do is, if you have on the internet, if you have people coming in on api.domain.com, it will receive that traffic, and it will automatically guide that user over to the place where you have the API services running in your Docker Swarm. This guy asks for domain.com/web. So you assign this guy to the web service, and they will become satisfied. Then you have backoffice.domain.com as a subdomain coming in here. So you have to find out where they are. And apparently there are 3 such containers running backoffice, 1, 2, 3. And so you will be able to transport that request over to the back office locations, and you will have a way to listen to the underlying Docker swarm, what is going on in your cluster. And as a consequence, you will be able to see that this reverse proxy, by the way, is also open source and is available on GitHub. And that is what I intend to use in this exercise. So I think I have that code already here in that location. And so what I want to do is, in order for this to create and work, we need to create a private network, or rather an overlay network. Overlay network inside our cluster. So we have these machines, right? And we have, each one of them have a public IP, each one of them have a private IP, and they talk to each other on the ENS7. They have ENS3 public IPs. And what I would like to do is, we are not talking about machines anymore, right? So I want to talk to the containers running inside here. These guys, I will be running containers in there, and I would like to have a network that acts as an overlay network for these containers, so that I can just interface directly with the container, so that I don't need to even look at this picture. Instead, I look at this picture and I have containers wherever they are, and I have a network which is an overlay network. And that network gives an IP address for every container on the net. I should draw it properly. Come on. Yeah, I should draw it like this. Yeah. So I get an entry for every container on the overlay network like that. And that is what I want to accomplish. And so each one of these containers will get an entry, an IP address on the overlay network, which means I need to create a network to begin with, which means Docker network create a network called Cloud Genius as an overlay network. So I will create that. I will go to my manager machine and say, you create. So it created a network for me. That's the network available. And it is now available across the swarm. So I can just refer to any container I like based on this network's overlay capability, and it's just available across the board, which is kind of beautiful if you think about it. I don't have to worry about dealing with machines. I just look at this network, which I have now. It is called Cloud Genius Network. It is an overlay network available across the swarm. I can now begin creating my stuff, and I can interface with them. So what I'm doing now is this action to create a service. It will be the traffic service, which is basically using the network called CG, which I just created. And using that network, I will install the traffic image in Docker. In Docker Hub, there is an image called traffic. This image, traffic software, is available in form of a Docker image. I want to use that here and use that image called traffic to create a traffic proxy. So I'm using that line number 9 as a reference to the image I want to use. And I have some constraints. I'm setting this constraint to run this traffic proxy only on the machine when the machine is manager. And I'm assigning some publish ports. I want to publish port number 80 and port number 8080 on the machine itself, on the manager machine. I'm mounting some source files and making sure I'm binding them so that I can listen to the Docker socket. This Docker socket listening action, as you saw in a picture before, is I would like to make sure that this traffic proxy is able to listen to the actions happening in my cluster through a listen as an API call. So this action needs the Docker swarm to expose the Docker socket. I need to have that Docker socket bind mounted. And then I'm telling traffic that you are running in a swarm mode and that the domain name that I have for you is going to be something that I like. So maybe this, or maybe something different. I think this name is taken right now. So I'll just change it to something else, like swarm.cloudgenie.us. Maybe that's the name. I'm just changing it to something else that is available. And then I would like traffic to watch my Docker Swarm through the API. So that is the command I will run on my manager. So I grab it, bring it here, and run it. So now I have Docker Swarm running with a traffic proxy. So it is preparing that, and it will make sure that the traffic proxy runs on the Swarm, and we should be able to get to seeing it. So now let's see Docker service ls. So traffic is running right now. It has 1 replicas, and it has, it is basically deployed successfully. So with that in our hand, what I would like to do now is put in a visualizer. This visualizer is helping us visualize what do we have running in our Swarm. Like it can be a large collection of machines. So I want to see it visually. What do we have? What do we got? And Docker doesn't give you tools to visualize. And I want you to be able to see it. So what I'm doing is using this software called Visualizer. It's a separate software that I'm going to install. It is called Visualizer. And it is Docker Visualizer. And so here it is. Docker Swarm Visualizer is a open source product that will make you look at what you have. You can get to see what's going on. So that is an image already available in Docker Hub somewhere here. And so I will use that image, visualizer image, to see what we have. I think this person who created Manomarks, he first created the visualizer, and I think it has now been superseded by his company's distribution called Docker Samples Visualizer. And so that's the product I want to use, the Docker Samples Visualizer, which is I think I have here. So I will run this visualizer also in my Docker Swarm. So I'll go copy that command here and run it. When I run it, the Docker Samples Visualizer product will be pulled, installed, and we now have a visualizer running. But then how do we actually visualize? How do we see? That's what I will need to understand, and so help you understand. And I'll let this finish and I'll show it to you. So you'll be able to see an empty Swarm running nothing, because right now it is running the visualizer and the proxy and nothing else. So you will see what you see. And let's see what we actually see when we see it. And so waiting for this action to finish, and then I will assign a DNS name to the manager machine. And the DNS name I want to assign is, oh, I made a mistake. I should have put a dot there, and I did not. Okay. So we'll have to work around it. Okay. No worries. We'll work around that problem by, the service converged. So we have to work around that problem by doing something different. What do we want to do is open a new terminal and go to sudo vi etc hosts and type the password correctly. The password is Cloud Genius, and then assign this mistaken name that we have like that without the dot. I made the typing mistake, and then assign it the IP address for the Swarm manager we have here. So Swarm manager, what is your IP address, please? Can you tell me? What is your IP address, dear manager? That one. So copy it and put it right here. And then like that. That should allow us to see what I did. What I did was workaround. I could not, sorry, do it again. What I did was I could not actually create a DNS entry like that because I missed a dot in there for some stupid reason. So I worked around it by assigning an entry like this in my workstation, which means I can now open my browser and go to swarm.cloudgenius, which becomes a funky domain. It doesn't actually, it's not a fully qualified domain, but it will work. So what it'll show you is that it will show you on the visualizer what I want to see. So I'll go to my command line again one more time here and connect to the worker machine I had somewhere here and find out Docker service ls. And I noticed that my visualizer is running on port number 8000. Okay. So I remember that. I copy the port number 8000 and come here. And there I type, what was the name? Swarm.cloudgenius, like that. And it will not show you anything, but you have to go to port number 8000 to see the visualizer. And there is the visualizer. Now, if I had not made that typing mistake with a dot in there, I should have succeeded with a proper DNS entry. But apparently, I was being stupid. I did not type the dot. So I made a workaround for that using etc host. Now you can see the visualizer. You can see that the visualizer shows you that it has 3 machines in the swarm, that there is a visualizer running in the manager machine right here, and there is a traffic proxy running right there in the manager. And these 2 workers are doing nothing. Okay. They're doing nothing, which is fine. We'll give them some work pretty soon. When you do that exercise, you want to make sure to not do this typing mistake like I just did. Put a proper DNS and use a proper DNS entry in your A records in your name control panel so that you don't have to do the workaround I did. I hope you understand what I'm saying. I think you do. Having dealt with me so many days, you now understand what I do. I hope, at least I'd like to hope. So back here. So we have these 2 services running. Let's go run some more. Let's run this service. The service is a simple who am I application. All it does is tells you I am, who am I, whatever the machine is. So who am I is a piece of code written by the creator of traffic proxy. His name is Emile. Emile, I don't know how to say this. It's a French name. Emile. Vogue. Sorry, I have no idea how to pronounce it, but that's the creator of the product called Traffic. And he has created a Who Am I application. And I want to run this Who Am I application in the swarm, right? I want to run it in the swarm. I don't know where it is, in which machine it is. I don't care about machines anymore. Right? I want to run it in the swarm on the network CG and call it Who Am I number 0. All I want to see is the output on port number 80, and that's what I'm really interested in. So I will go copy that action and run it here and let it go. So it pulls the Who Am I image and runs it. I don't even care where it wants to run, whether on machine manager worker 0, worker 1, I have no idea, and nor do I care. But I want to find out where it actually went. So we'll go here and we find out it goes to worker 0. I was on manager machine, by the way, just remember. I ran this command to run the Who Am I service on the manager machine. And you know, it's a swarm, it's a collection of machines, a cluster of machines right now. So it is able to allocate and schedule an application wherever it thinks is appropriate. So it decided that the who am I needs to run in worker 0. So there it is, running. Awesome. Now what? I want to actually get some output of that. So I will like to curl the output of the machine itself. So this domain name I did not use, so I want to use some other domain name like I have. I made a mistake. So I would like to make sure that I keep track of that mistake. I made a mistake in typing the name as Cloud Genius. And so that is what I want to now use in the exercise. So the IP address here is also not correct. It is from the old example. The last time I ran it, this time the IP address is different. So we'll grab that IP address from our inventory. Inventory should have the manager IP address, and that is this address. So we'll grab it, close it, bring it here, and paste it in all the places and save it. And do the same again for the who am I one action, which is the same IP address replaced in 4 different times like that, and save. And at the same time, this cloudseminar.com, the mistake I did needs to be replicated. Swarm.cloudgenius and save. Now let's do the who am I exercise. This exercise will help you understand what are we dealing with. So I'm going to curl that particular who am I 0 application that I'm running. This application, who am I 0, I'm going to curl it. Let's see what it responds back as. So here is the machine. And I see the response. I see the response is coming from a host name with that number, which is actually a container name inside. There are IP addresses. These IP addresses are the local container IP address. This IP address corresponds to your overlay network. Maybe this IP address, I think. This is the IP address for the overlay network. This is just the get response for the curl command. This is the name of the host that is responding to you. The user agent we are using is curl. And as there is the real IP address is the IP address that the host is looking at, is the IP address which is, I think, the point, the manager's endpoint, which is interfacing with the overlay network. That's what it sees as the real IP of the action curl. Bottom line, what you saw in this example is that the application is responding to my request. Now, if I go to the swarm and say, can I see this myself in a browser? You can. You need to make another host entry with that name in your etc host file. What does that mean? It means you have to open a new terminal and go edit, sudo vi etc host file, and then provide the password, and then add an entry pretty much like that with this name. And now you can open your browser. Rather, I can open my browser, not you. You cannot do it because I made that mistake, which is I used the name Cloud Genius as opposed to cloudgenie.us. That is not reachable unless you make the hack, which I just did in etc hosts. Then you can reach it. And so now you can see that I can reach it through the browser. And I see the same output which I expected to see on the curl command. So you can basically run an application inside the swarm, and you're not dealing directly with the machine. You're just interfacing with the cluster, and you're able to see the response from the application that you see in this example. Next, what I want to do is talk about scaling these containers. Like we have we can have any number of these containers. We have just one right now. This who am I is just one container. I would like to scale it now. So I'm to scale it who am I 0 into 5 containers, like that. So what I will do is go to my visualizer, and on the command line, not this command line, but the other command line, on the manager 0 command line, what I want to do is put the visualizer in 1/2, like that. And then scale the number of application containers from 1 to 5. Let's do it and see how quickly it happens. And you can see it visually on the visualizer. It already is running 5 who am I zeros. It spread the load across evenly. 1, 2, 3, 4, and 5. It distributed the load of these 5 tasks, or rather 5 instances of the container. Now you see Docker service ls. I should just type it manually, Docker service ls. And you can see that currently we have the traffic container, we have the visualizer container, and who am I container, who am I 0 container replicated 5 times. That's this action. Now we can scale it to an arbitrary number, like really literally arbitrary. I can make it 35, and it will become 35. It'll become crowded, but it will scale. There we go, 35 containers in the visualizer. And service converged, and you can see that it is running 35 containers right there. You want to scale it down, you just say that scale it down to 4, and it shrinks to 4, and it's already shrunk. You can scale it down to 1, and that is also easy to do. And at the same time, when you scale it back up, let's say, let's say 45, and just arbitrarily any number. It's a very small container. It can handle these 3 machines can collectively handle. So it's scaling up. And now I will show you the action that I wanted you to see, which is the action of load balancing, which is what you will see now. Oops, what did I type? It's already 45. Why did I type it again? Okay, so Docker, come on, Docker service ls, and we see 45 containers running. Now I want to see what this particular service is going to show me when I visit. So I see that this container 3 Charlie brother 3, that guy responded. Okay, I will run it again. And I see another brother, Echo Foxtrot 07 responded. I run it again. 5F57 responded. I run it again. 75C7 responded, and I run it again. There are lots of containers running the same service, so that it just chooses in a round robin fashion, assigns a container to the person requesting that resource, and responds, the appropriate container responds back. I want to make sure that you understand what I'm talking about. So please tell me that you do, because I'm not sure. So please tell me that you understand this, or if not, ask questions. The thing that I want you to think about is that when I shrink my containers to 1, and then I will see the same action responding back from 904 alpha. Every time you will see the same guy responding back. See that? 904 alpha, same guy responding. If I have the machines, rather containers scale to number 2, then you will have 2 containers responding in a round robin fashion, just like that. This one is the 904 alpha, and this one is the other one, 0B88, and then again 904 alpha, and then 0B88, and like that, and like that, and like that. It will toggle. It will go round robin. And you can, of course, adjust the number of your services to 3. And you now have 3 services running. And that's the, oh, what did I type? 33 or something? Did I type something else or what? 23? I think I typed 23 by mistake. I wanted to type 3, but whatever. So I make it 3. And so it becomes 3. It's so easy to manipulate. It's not even a hassle. And that's the point I want to drive to. So make sure that you get this idea clear, because this is the idea that we are talking about involves a couple of things, quite a lot of things actually. It's a fairly elaborate exercise. So let's go see what we did. There are still more steps to do. It's a never-ending game. I can keep on extending the exercise until cows come home, but let's see how much time we have and what is the area of interest that you have. So we'll match it. Today is our last day for DevOps, and I wanted to point out to one thing to all of you, just making sure that I make sure that you understand what I'm talking about. So that thing that I wanted to highlight to you is in Boeing LTP, when you submit the certificate, that is when your salary deduction stops. If you don't submit your certificate, then LTP will deduct from your salary. So please make sure that you understand this aspect. So what it means is go submit the certificate. You don't want your salary to be deducted, right? That's one thing. The second thing I want you to remember is that in case where a training program is required as a part of a job, if that is the case, if it is a part of your job, which I think in most of your cases that is the case, when this kind of training is relevant to what you do on a day-to-day basis, then there are no tax consequences. So make sure that you understand that very clearly. There is a tax consequence after you cross some threshold limit. I don't know what that limit is, but there is some number, and you cross that number, you go beyond the threshold, and then for the rest of the matter, you have to pay income tax or something like that. That may be the case. But since most of you, I believe, are working in groups where this kind of work is like what you do on a daily basis, and it's actually a part of your job, then in that case, there is no tax consequence. So just study this area carefully. I do not know the details, but I think you know what I'm talking about. I hope you do.
Yeah, I think for certificate uploading LTP, when we I generated normal. I don't know about others. I generated all 3 together. So maybe I was for the first session. Once it's done, I was trying to upload it. It took it, but they rejected it because it for 3. Once I finished 3,
they want all 3 together. I see.
Yes, yeah.
They want all 3 together. Well, that's fine. That's not an issue. But check this tax consequence issue. So that part you should understand, and just read carefully about LTP. I don't know. I've never seen it, but what I know is this one thing: if it is a part of your job, that there are no tax consequences. So make sure you rationalize that. Okay, that's done. Back here. I was summarizing and then do another exercise I have for us, so which is this one. Yeah, the other exercise is actually enabling stickiness. So the sticky part, we'll look at that also. Let's go see this stickiness is missing in here, right? You see that the three services that are currently running. Where is that? Come on. No, Docker service list, ls. Yeah, we have three services, three containers running for that service. Who am I? So if I now go, it will go round robin. One host number 77, another host number A5, another host number 0B, and like that. It will go round robin like that. Keep round robining, keep in a circle. What I will do is now create another service called Who Am I 1, and that service will be sticky, because I'm choosing it to become sticky, because I'm using a traffic proxy load balancer stickiness to be true. So now let's see what happens when I run another service, which is a sticky flag incorporated. And this should enable a new service called Who Am I number 1. And now I should be able to go ping, or rather curl, that number 1 service, which is, give me a second, curling, listing the services. We have one replica of the Who Am I 1, and that is not enough to test for stickiness. So I will scale it. How will I scale it? I will say Docker service scale Who Am I number 1 to say 3 replicas. So now because of this Who Am I number 1 service, and as a consequence, I have Who Am I 1, I have Who Am I 1, and Who Am I 1 spread out in 3 different machines, 3 containers running 1 service in 3 different machines. Same with Who Am I 0, Who Am I 0, and Who Am I 0. Those are not sticky. Who Am I 1 is sticky, because I chose the stickiness flag. And now we should be able to see how the stickiness performs. And unfortunately, since I made that .us mistake, you cannot run curl unless you do a Etsy network, Etsy host hack in your local machine. In that case, you should be also able to see the same thing. So if I curl this thing on my machine here, I will find it is always this D1 host. Oh, what happened to the stickiness? Hello? Hello, sticky? Whatever happened? Whatever happened to the stickiness? I thought you will stick. Oh no, it will not stick. I'll tell you why. The reason it will not stick is because you have to actually use a cookie to make the session persist. That's why it is not sticking. So this curl has a way to create cookies and use cookies to then ensure stickiness. Without using the stickiness feature of curl, it will not stick. You have to actually have the browser deal with the cookie and ask for the same cookie for the same session that generated the cookie to get to the same machine. In our example, up until now, we haven't actually used cookies in curl. But if you go to this thing in my web browser, it will be sticky because the browser itself is capable of creating stickiness because Firefox is automatically getting a cookie in hand. I need to again modify my host configuration, which I need to do right here, and do that in my sudo vi etc host file. And did I typing mistake? Password. And then create another entry at the bottom here for that line. Now I have that new node available, so I can go to this location. And I will find that it is always 922, no matter how many times I refresh. And this is sticky. This is sticky because this browser is actually maintaining a cookie in here. You can see the cookie right there, where you can see that the cookie is coming from who am I, and the cookie is generated by the traffic backend for this host. And this cookie generation automatically happens in Firefox, but not in curl. So when you want to do a cookie generation in curl, what do? You create a cookie and save it like that. You create a file called cookie.txt and save it as you browse. So now we have a file called, now we have a file called cookie.txt right there. The file contains the cookie itself. Now that we have this cookie file available, we will use this cookie the next time. We created the cookie when the first time we visited, and in subsequent visits, we should be able to use the cookie and ensure stickiness. So now we are going to use the cookie this time. The cookie file is stored locally in our machine and in that location. So I'll use that cookie, and then using cookie, I'll go browse the website and I get D1, D1, and do it again, and I get D1, D1, and again, and again, and again. It is stuck. It is sticky. It needs to be sticky because that's what we chose. And we have, I think, Docker node, no, Docker service ls showing 3 services of the sticky nature and 3 of the not sticky nature. And we are able to see that the sticky one is actually sticking because the cookie that we have, which is this file. And that cookie is stored in the browser in that location. And you can clear the cookies, all of them, everything, clear now. All the cookies are gone. And now you can see if you refresh this one time, this 922 might change. And I will refresh. And it did not. And that's okay. But now it is stuck because we now have a cookie. And the cookie is showing up here in the browser. And here is the cookie. And that cookie is generated by the traffic backend. So that is cookie persistence in a container scenario. You have a Docker swarm that visualizes like this. And you will see other types of visualization tools. You will also see that this proxy that we have, that the Docker Swarm proxy, traffic proxy, also gives you a UI dashboard that looks like this, which shows you in the back end what whoami services are running, whoami 0, 1, and 2, and 4. And then there is a whoami 1 service running with whoami 1, 2, and 3. On the front end, we have a whoami 0 that responds to these services on the back end, 1, 2, and 3. And on the front end, we have whoami 1, which responds to services 1, 2, and 3 on the back end. We also have another user interface here to show the health of the cluster and how many times we have had 202 or 404 responses, in page not found responses. And just a little bit UI provided by the traffic proxy itself. But that is something you get with the proxy. The proxy is giving this to you. More important than looking at the UIs is to actually understand the core capabilities of the clustering that we saw today. What we did was we began using Ansible. We discussed briefly about having the type of machines and type of workers, or other managers and workers. And we can have any number of these guys as long as it is odd, and any number of these guys, even or odd, doesn't matter, and create a large cluster of Docker Swarm. The way to create a cluster is to have these managers generate a token, and the tokens are of 2 types, one to join as a manager and one to join as a worker. And then you get a large swarm. This tool we used to create a swarm. We chose 3 machines to create our cluster. This is a small one. it's simple to do this actually. If you want to extend the idea to grow it, it's also very easy. All you need to do is go back here and start another. Oops, I think my mouse is behaving improperly, but I go back here and go to the location, and you can select a Debian machine and go select the size and select private networking and select this private network, and then select your private key and assign it a name, worker2. Maybe get 10 more workers. It doesn't matter how many you want, and just get their IP addresses in hand and deploy them, and then grab that IP address for worker2 as soon as it becomes available. Once that worker2 IP address becomes available, you can take it back to your inventory here and add one more line like that. Copy, paste. And now you have a Docker swarm expanded or grown like this, and save. And what you will do now is wait for the IP address to show up in here and grab its IP address from there, copy, and bring it here to the location and dump it there. Now we have a production worker2 available as a machine, and so we'll save that. And what all we need to do now is to make sure that we are making this new machine go through our basics, our packages, our private IP, our host file, and our Docker YAML and our swarm. These 6 plays need to run. Now we know Ansible is idempotent, right? Idempotent, meaning you can run the same command over and over and it doesn't matter. It doesn't hurt. And so we will run all these commands just like that without having to change anything. We just Ansible playbook and then playbook basics and just run it. It will do nothing on the other machines, just focus on this machine and come back and do its thing, like worker number 2, it is setting up swap. And then it will proceed ahead with the next action needed. We'll reboot that worker2 machine, and then we'll install packages, private IP, and all other steps. And we should have this new worker2 join the swarm. You will see that join. You will see it joining as soon as we finish this action. And that action is what I want you to be able to see, because that's how you grow and shrink a large collection of cluster. So I'm just showing you how you scale from 3 to 4 machines. You can scale it from 300 to 4,000 machines. It doesn't matter. The same process you will apply. Same method you will apply for a large scale configuration. So I'm waiting for this action to finish. We should finish this thing in 2 minutes or 3 minutes, maybe max 3. And I think in the meantime, I should answer questions because we are already at the 6 more minutes left to go. So questions are welcome while I go through this action of adding one more cluster to grow the swarm. And then we will also shrink the swarm at the very end by killing off one of the workers. So we just kill worker number 0 or 1, and we have added a worker number 2, which is nice. So we'll see the growing action, shrinking action. And at the same time, you will see that these things that are running in the cluster, these visualizer, it will just dynamically handle the workload and shift it to other machines. You will see it live. As the situation progresses, you will see the action happening live in the visualizer, where it will automatically load balance and move live running applications from one machine to the other. And when a machine dies, it will just yank off the load from that and put it on the other machines and spread the load. You will see that as soon as the action finishes. Questions are welcome.
So Nilesh, I have a question. I really like the Docker visualization and the dashboard, but does it get kind of unwieldy once you start doing like enterprise scale deployments?
Yes. Yes, it does. And
Okay.
this is not this visualizer is not for production. It's just for academic use for me. Uh, I just want to show it to you. Otherwise, it's so clumsy. You
Yeah.
cannot even see anything what's going on. That's the reason I use the visualizer. This is not a professional production tool. For production scenarios, there are better visualization tools available, which I think we'll talk about in monitoring segment in the third segment, which starts, I think, on Wednesday. And at subsequent time, I'll show you better tools also. But this is just a quick and dirty to show you quickly as to what's going on. So that first action that we finished, basics action finished. So we should be able to now reboot the machine. So we'll say Ansible ad hoc. What is the name of the machine? Production worker 2 dash A and reboot. Just reboot that one machine, please. And it rebooted. It's supposed to fail, so it fails. Nice. And then we'll ping all of the machines and run the other exercises as soon as the last machine is ready. And so Ansible all, please ping all of them. And so the machines are all ready now. So we should now finish off the other books, Ansible playbook, the playbook for packages, and then the playbook for private IP and the host file and Docker and Swarm. That's how it takes. The rest of the books are very quick. The basic book requires swap file in setup, and that's why it takes a little time. But apart from that, these guys should be, in package install also takes a little time. Questions are still welcome. I don't know why my video camera is not working today, so I cannot even look at you. So it looks like I'm talking to my computer, but I'll see what's going on with the camera. Yep, it finished. You can see that it changed exactly that one machine. And now the next one, play number 2. And private IP play is a very quick one. It should just do it fairly easily. Put a stanza, worker number 2 gets a stanza incorporated for ENS number 7, the internal adapter. And then we set up our number 3 host file, which is basically letting every machine talk to each other by name. And so it is doing that. And it did. And then we have the number 4 is not necessary. Number 5, set up Docker. So it sets up Docker on all the machines and then responds back that it is done soon. And then Swarm comes along, and you will see as soon as the Swarm kicks in, the visualizer shows you the 4th machine popping up, or the machine number worker 2 pops up. As soon as Swarm is kicking in, it will pop up in the visualizer. So Docker is getting installed on worker number 2, and then we should run the Swarm step, the last step. And here we go. The last step should kick in and bring the Swarm, or rather bring number 2 into the Swarm. And that's what will happen. And it's taking tokens, passing on tokens to the machines and asking them to join. And it joined. And where is our worker number? Hello, where is my worker? Unable to connect. What? What just happened? Hold on. Hello, there we go. So we have the 4th machine there. Worker number 2 showed up. And now I will create some havoc. So my havoc is going to destroy this machine. That's my plan. Worker 0, you die. Let's go kill it. Hello, worker 0. Bye-bye. Destroy. You die. Now what happens? Let's see. Let's see what happens. So refresh. It should die. That's what is happening. But it's not dead yet. So come on, die quickly. It's not dead yet. And this machine is a spurious machine. I don't need it. So you should also die. Go. Bye-bye. And now I have, how many? We got 3 machines now. Yes. So now look at the visualizer. Worker 0 is dead. And worker 2 got the load. Dynamically shifted. Beautiful. That's what I wanted to show you. You saw it. Success. It's a difficult exercise to run it live and show to a bunch of people. It's hard. But sometimes it doesn't work. Today it worked out okay. That's goodness. So thank you for bearing with me in my glitch that I did with this stupid typo. Otherwise, you should have seen all these things on your machine also as I was doing it, because it would have been a DNS name. Without the dot, I made a typo. And apart from that, I think most of the exercise went well. So shrinking, growing, scaling, dynamic adjustment of workload, load balancing, traffic proxy, stickiness, all of those things. And you can run any application you like here. This is a who am I application. You can run WordPress, you can run databases, you can run whatever you want. It doesn't matter. As long as your underlying machines are big enough to hold these containers, and there are plenty of them, your containers will run just fine and they will live. They will live and they will, they will scale within the underlying hardware. Within the limits and the bounds of the underlying hardware, it will scale, grow, and shrink. And you can also scale and grow, shrink and grow the machines themselves. The machine scaling happens in Ansible. The container scaling happens automatically and through Docker services that you saw me do. And that's the session today. With that, I will like to stop recording. I'm still here for questions.